Hello and welcome to this video on content upgrades in Corda. My name is Asutosh Meher and I'm a part of the developer relations team at R3. My job here is to help developers onboard to Corda and make their lives easier as they develop with Corda, with an end goal to obviously make Corda the #1 blockchain platform for developers across the world. As part of my job, I go out there, meet developers and try and understand what the pain points are. And one of the most common query that I get is around upgrades. There is always someone who would come up with this topic saying, how do I upgrade my app? So I tried to learn more about it, and it's one of the general things with any blockchain. It's like the very nature of blockchain, which is immutability, that makes it so powerful. Is as well, it's as well the problem, right? So things once recorded into a blockchain, you can't really change it, and it applies to your code as well. Which means once you have your smart contract and you've deployed it onto a blockchain platform, you can't really change it. It becomes immutable. That's where the problem lies. So no matter how much of hard work you put into it, or how much thinking you do into designing such things, you're always going to have something that you did not anticipate it, right? And even when for a moment I assume that you did everything right, there is no bugs, no breaking functionalities, it all works like a charm. But what if someday you need to have a new feature incorporated into your application? That's evolution, that's how it works, right? You can't really stop it, and that's where upgrades become inevitable. So let's get into it and let's understand what Corda offers when it comes to upgrades. If you follow the development of Corda, you may already know that one of the promises that we make is to try to make it easy to use for developers. Now, unlike other platforms, we haven't reinvented the wheel by coming up with new languages and protocols. But what we do is we use already proven technologies which are available in the market and are well known to most of the developers across the world. So in our quest to make upgrades even easier, we come up with different strategies to do upgrades with different releases of Corda. The idea here is to try and make upgrades even easier than it was in the previous release. The current recommended approach as of Corda 4 is to use signature constraints. But before we dive deep into it and try to understand different ways of doing upgrades in Corda, let's understand how upgrades really work in other blockchain platforms. As I said earlier, the blessings of blockchain, which is immutability, which also makes it so powerful, is also occurs when it comes to upgrades. It makes upgrades really difficult. So how do platforms upgrade? Let's start with the most earliest implementation of blockchain, that is Bitcoin. Bitcoin is a distributed ledger purely to record balances, and there is no extensive support for smart contracts. So an upgrade to the Bitcoin protocol means an upgrade to the core code which everyone runs. And when a new version is released by the developers, the nodes are required to vote on to whether they want to upgrade to this new version or not. And once majority of the nodes agree to upgrade, the new version becomes a new accepted protocol. Now this may seem very simple at the very first look, but in practice it's a nightmare to pull off. Ethereum, on the other hand, supports smart contracts. Thus developers can write their own smart contracts and deploy onto the Ethereum platform. The smart contracts, like any other thing in blockchain, would become immutable once deployed. So nothing can change once a smart contract is deployed. So an upgrade means a new smart contract has to be developed with the upgraded code and then deployed onto the network. And in order for the outer applications to be able to interact with this new smart contract, a versioning system is needed, which would basically redirect the requests to the correct version of the contract. Also, the contract needs to be carefully designed so that the data is loosely coupled with the contract so as to avoid any data migration effort during the upgrade. That's Ethereum. The way Corda upgrades is by the use of something different called contract constraints. Apart from managing contract upgrades, constraints is also the way how Corda ensures that the correct code is executed to verify the transactions. Now, each state issued in Corda is tied to a constraint. The constraint is something which defines which version of the contract the state is compatible with. And if the state is verified against a version of the contract which doesn't satisfy the constraint imposed on the state, the transaction would not go through. Thus, constraints solve two different purposes. One, it helps parties to agree on upgrades, which means parties can make sure that they're transacting with a counterparty on an agreed version of the contract, because any deviation from the agreed version would result in a failed transaction. Two is it prevents from attacks. An attacker with a malicious intent cannot install a contract of his choice and start executing transactions in a Corda network. That's because the contract constraint would not allow such an activity. So if a node receives a state as part of a transaction which doesn't satisfy the contract constraint, the node would reject the state and the transaction would fail. So now let's move to the types of constraints available in Corda. The first type of constraint that was supported in Corda was hash constraint. The constraint itself was the SHA-256 hash of the jar containing the contract. Thus only one version of the app can be used with the state, as any change to the content of the jar would change the hash of the jar, and the previously issued state would become incompatible with the newly produced jar. This was very limiting and required an explicit upgrade for every small change, which means all network participants would have to manually agree on the upgrade for it to actually happen. Hash constraint was the only constraint available till Corda 2, and thus the only way to do an upgrade back then was by the explicit approach. However, if malicious app creators is a threat to the consortium, this can be the way forward. As explicit upgrade was a very tedious process and required all participants to manually agree on upgrading, Corda 3 introduced something called as the compatibility zone whitelist constraint. This made upgrades a lot easier and also made way for implicit upgrades. By implicit, I mean we could pre-authorize certain versions of the contract and would not require all participants to simultaneously perform the upgrade. In fact, the participants could simply replace the old jar with the new one and the upgrade will be performed. With compatibility zone whitelist constraint, the compatibility zone operator would provide a signed whitelist of list of hashes of the jars as part of the network parameter. Any of these hashes would be valid and accepted by the platform. Thus, parties can now wait before they upgrade to the newer version in case they are not ready to upgrade to the newer version for whatever reasons. This also allows multiple versions of the contract to coexist in the network and the parties still be able to transact. Thus, a party with an older version can easily interact with the party with a newer version. However, when a party with a newer version wants to interact with a party with an older version, he may ask the counterparty to upgrade to the correct version before transacting. Having said that, any change to the network parameter would require the node admin to manually accept the changes and restart the node, which is a limitation. Even then, the new approach still allowed some form of ease when it comes to application upgrades. This limitation, however, is taken care with signature constraint, which is our next type of constraint available in Corda. Corda 4 introduced yet another constraint called as signature constraint. While the compatibility zone whitelist constraint was a good way of allowing implicit upgrades, however, it had a lot of dependency on the zone operator, which is not really desirable in most cases. Thus, the goal of introducing signature constraint was to eliminate the involvement of the zone operator in the upgrade process, while also eliminating the need to update network parameters. With use of signature constraint, the platform supports any version of a jar that is signed by a specific key or a composite key. Thus, any Cordapp jar would be accepted by the Corda framework as long as it is signed by the same key. Signature constraint is the default contract constraint as well as the recommended way of managing upgrades as of Corda 4. As we understand, signature constraint requires signing of the Cordapp jar containing the contract, and the signature constraint is used by default. Jar signing is also enabled by default, and the Corda development key is the default key which is used to sign the Cordapps in the development environment. This can, however, be changed in the build.gradle file of your contracts module as shown in the slide here. You can use the options parameter in the build.gradle file to configure your own signing key. Once this configuration is in place, your Cordapp will be signed using the configured key during the build process. You may also choose to disable signing by changing the enabled parameter to false, just in case you wish to use any of the other constraints available in Corda. There is also a fourth type of constraint available in Corda called the always accept constraint, which basically disables the contract constraint feature and any version of the app can be used. As you can understand, this would be insecure and is generally used for development and testing purpose and helps the developers to bypass the constraints while development. I have been talking about explicit and implicit upgrades in this video, so let's look at them in details. When you want to do an app upgrade in Corda, there are two possible approaches that you could take: explicit and implicit. Explicit is generally the hard way of doing an upgrade. It requires a special type of transaction called the contract upgrade transaction, which is provided by the Corda framework. All parties need to manually initiate the upgrade process by executing the contract upgrade authorize flow. And once all the parties have authorized the upgrade, one of the parties can go ahead and start the upgrade by executing the contract upgrade initiate flow, which would actually perform the upgrade. One point to note here is that the contract constraint is actually bypassed in this approach. All the existing unconsumed states are consumed and new unconsumed states are produced, which would now be compatible with the new upgraded contract. The upgraded contract must implement the upgrade contract interface, which would require you to provide an implementation of the upgrade method. This method would take the existing state as an input parameter and return the new state, which would be produced as an output of the upgrade. The logic needed to transform the old state to the new state is required to be coded in the upgrade method. The logic could be simply copying the data from the old state to the new one, or some other complex logic as your situation demands. When the contract upgrade authorized flow is executed, all the unconsumed old states that are passed as parameters to the flow are marked as authorized for upgrade and stored in a persistent storage of the node. Once the contract upgrade initiate is executed, these authorized states are fetched from the persistent storage and marked as consumed, and the upgraded contract's upgrade method is called to produce the new states. Implicit upgrade, on the other hand, is done by simply replacing the old contract jar with a new one and restarting the node. This allows multiple versions of the contract to coexist at the same time in the Corda network. This also allows parties to defer the upgrade if they are not ready to perform the upgrade for some reason. While implicit upgrade seems very easy, developers must ensure to maintain backward compatibility for smooth functioning of transactions. For example, any new fields introduced in the state should be marked as nullable so that the old issued state could be deserialized properly. While we talked about upgrading contracts in this video, flows are also a part of the application and may need upgrade more often than the contracts. And since flows have nothing to do with contract verification, we recommend to package them in a separate jar. So you should ideally have two separate jars for your application, one for contract and state and the other for flows and services. This allows you to upgrade flows without worrying about contract constraints. We recommend this approach as we anticipate that most of the changes or modifications to the applications will be in the flows and services, while your contracts and state would be subject to minimum modification. Thus, having them in separate jars would remove the overhead of dealing with contract constraints when upgrading only the flows or services. Upgrading flows in Corda is pretty simple. All that you have to do is replace the old jar with a new one containing the updated flows. To support different flow versions, you could take advantage of the version parameter available in the initiating flow annotation. This will help manage situations where the counterparty is not on the same version of the flow. You can check the flow version of the counterparty available to you via the counterparty flow session object and execute the appropriate code, thus allowing backward compatibility. Few things to take care with flow upgrade is to make sure that the send and receive between the initiator and the responder are in sequence and there is no missing send or receive. Out of sequence or missing send receive could result in flow being hanged indefinitely. Also make sure that the type of the object you send receive matches. Any mismatch could result in an exception being thrown from the flows. Now that we have a basic understanding of upgrading applications in Corda, let's look at a small demo and see it in action. I have put a link to the code base used in the demo down in the description. Please feel free to download and play around with it. Before we start with the demo, let me give you a brief idea of what we are going to do. You can see that I have got different versions of contracts and workflows available in my workspace. And we are going to use these different versions to cater to different kind of scenarios that may require an upgrade. The Cordapp as such is a very simple Cordapp where we are going to register vehicles and transfer ownership of those vehicles. And a Corda network is a very simple network containing of 4 nodes and a notary. The nodes are the RTO or the Regional Transport Office. It will be the registering authority for the vehicles, which will be issuing registration numbers for them. And we have two parties, Party A and Party B. These would represent the owners of the vehicles for whom the vehicles will be registered. And then we have a police party. The police party as such would come into play once we introduce a new feature, that is once we upgrade and introduce the feature called challans. The challans could be issued by the police party when there is a traffic violation done by any of the owners, which is Party A or Party B. Challans can be thought of as legal documents that are issued against traffic violations. It's type of a receipt against a payment. I have already started the network and the nodes are up and running. The initial app that's deployed to the network is the version 1 of both the contracts and the workflows. They have a very basic functionality of registering the vehicles and doing transfer of ownership of the vehicles. So now let's go ahead and register some vehicles for Party A. And we should be using the RTO's terminal to initiate the flow to register the vehicle. because the RTO is the registering authority and he should be the one who should be registering the vehicles. So to register the vehicle, we need to run the register initiator flow. So I've just written down all the commands that I'll be using during this demo. So this should save me from some typing. I'll just copy these two commands and paste them in the RTO's terminal. What that would do is register two vehicles for me in the name of party A. That's a parameter which I have provided as owner, that's party A, and also I have provided registration number, which is a unique registration number for the vehicle. The two commands have been successfully run, which means the flows have executed successfully, and now I should be having the vehicles registered in the name of party A. To check that, I'll run the run vault query command, and you can verify that we have two states available here, and the two vehicles are registered in the name of party A, which could be verified from the owner parameter here. I could also run the similar command on party A just to check that the states are also available with party A. However, party B and the police should have nothing in their vault, which could be verified with the same command. And that's because Corda uses a point-to-point communication, which means there is no global broadcast and the states are shared on a need-to-know basis. Now the next, what I'm going to do is do a transfer of one of the vehicles from party A to party B. And to do that, I'll need to copy the transfer command or the transfer initiator flow and run that from the RTO's terminal. So once this is done, I should have one of the vehicles transferred from party A to party B. And again, to verify that, I can use the vault query command, copy this and paste it on the RTO's terminal. Now you can see that the second vehicle, which was earlier issued to party A, is now issued to party B. And we can also verify the same from the party A's terminal. You could only see one state now available because the other has been transferred to party B. And party B also has one state, which is the vehicle that we just transferred. So now that we have some state issued to all the parties, that is RTO, party A and party B, we are now ready to perform an upgrade. The first thing that we are going to do is a flow upgrade. That's rather a simple upgrade where we are just going to change some of the flow logic in a transfer flow. So the version 1 of the flow, if you could see here, if you can see here in the steps that are executed in the transfer flow, there is no collecting of signatures from the counterparty. That's because we do not have the collect signatures flow available in version 1 of the code, which means that the party A and party B are included as non-signing parties to this particular transaction. So we are going to add that particular code in version 2, where for a transfer of vehicle, party A and party B would be required as signing parties. Currently, we are not going to do an upgrade on all the nodes, but what we are going to do is just upgrade RTO and party A. This is to demonstrate a particular scenario where all the parties may not be on the same version of the flow, but they are still able to transact. Now, of course, to do that, we'll need to write backward compatible code. And to understand how to do that, let's look at a flow classes. First of all, let's have a look at version 1 of our transfer flow. That's because this is the one that we are going to upgrade. It's a very simple flow. All we are doing is doing a vault query to fetch all the vehicle states from the vault, and then filtering down all the states on the basis of the registration number to fetch the vehicle of our choice. We're creating the output state with the updated owner, and then we are creating the command with the RTO as the signing party. Note that there is no other signing party, which means the other parties are included as non-signing parties. And then we are creating the transaction builder with the input, output, and the commands added to it. The input here is the filtered state that we fetched from the vault. The next thing we are doing is verifying the contract by calling the transaction builder.verify command, which would internally call the verify method of the contract, and then signing the transaction, and finally calling the finality flow, which would notarize the transaction and record the updated transaction onto the ledger of all the participants. Now looking at the responder flow, there's nothing much happening here. All we are doing is calling the receive finality flow so that the counterparty is able to receive the notarized transaction and record the updated states. So now let's move on to the version 2 of the transfer flow and see what has changed. The first thing that you would notice is the version parameter, which is included as part of the initiating flow annotation. This is used to indicate the version number of the flow. Down here is where we are writing our backward compatible code. And if both of our counterparties are on version 2, we introduce them as signers to our command. Otherwise, we leave it as it was. And again, down here, we are doing a similar kind of thing where we are checking the version of the flow in the counterparty to decide whether we want to run the collect signatures flow or not. Also notice that we are using a flag here. This is for the scenario where only one of the counterparty is upgraded to version 2 and we only want to execute the collect signatures flow if both the counterparties have upgraded. And in such a case, we need a way for our counterparty flow to be able to identify whether it should run the signed transaction flow or not. For signed transaction flow, by the way, should only be run if the collect signatures flow has been called by the initiator. And we do not want our counterparty flow to execute the signed transaction flow if the collect signatures flow is not executed at the initiator's end, as it may result in an exception being thrown. Now let's look at the responder flow from the version 2 of our flows. As you can see, we have used our flag which we passed from the initiator to identify whether we should run the signed transaction flow or not. So that's how you write backward compatible code, and the example here should give you a basic idea of how to do that. So without wasting any more time, let's go ahead and do the upgrade. To perform the upgrade, I have a small script called the upgrade.sh, which is available in the script directory. And I'll use the script to do the upgrade. And what it does is basically it would copy the version 2 of the workflow jar and replace it with the version 1 in the RTO and party A's nodes Cordapp directory. So let me just run this script. Need to go to the terminal, go to the script folder. That's where the script is, and just run the command. So now that we have done this, next we need to restart our nodes. So I'll just restart the RTO and the party A node. That's because these are the nodes which we have upgraded. Both of my nodes have now restarted and they should be running the new version of the workflow now. And just to show you that the nodes Cordapp directly actually contains the updated code, I'll just go to the Cordapp's folder of party A and we have V2 workflow here, while party B, which we didn't upgrade it, it's still running the V1 workflow. So what we are going to do next is to check whether things are working fine. So first thing I'll do is to start a registration flow from the RTO's terminal. This should register a new vehicle for party A. Know that both RTO and party A are on the new version and the flow has successfully executed, which means my vehicle should have been successfully created. The next thing that I'm going to do is transfer one of the vehicle which was already created. If you notice, this particular vehicle with registration number 2322 was already created with the version 1 of the code. So I'll just try to transfer this particular vehicle from party A to party B. And there you go. This has worked, but if you see here, we have the collect signatures as grayed out. That's because party B is still on the older version of the flow, and that's why, as we have written a flow in a backward compatible manner, even though the flow has successfully executed, the collect signatures flow was not called. For the collect signatures flow to work, we need all the parties available in the transaction to be upgraded to version 2 of the workflows. And that's what we're going to do next. We're going to upgrade party B to version 2 of the workflow. And how do I do that? I'll just copy this script here, which will upgrade party B with version 2 of the workflow. And go to my terminal, paste this. And if you could now see, we have party B upgraded to version 2 of the workflow. Once that's done, the Cordapp has been replaced. I will need to restart party B node. So exit and then restart. So while that restart, I'll just copy the commands. We again need to check whether our registration is still working, just to make sure that nothing is broken. And yeah, it works fine. Now let me do the transfer. So as I do the transfer, you could see that the collect signatures flow is now getting executed, which is depicted by the tick marks here, which now indicates that all of my nodes are now upgraded to the updated version of the flow. And that's why the section where we wrote the code around if both my counterparties are on the updated version, then we should run the counterparties flow. That piece of code has been executed. And that's how we do flow upgrades in Corda. All we have to do is write our new flows in a backward compatible manner, replace the old jar with a new one, and restart the node. Next thing that we are going to do is contract upgrade. We'll be doing it by the implicit approach, and the constraint that we are using is the signatures constraint, as the vehicle state that is issued onto the ledger is using signature constraint, which can be verified using the vault query. And you can see that the constraint that is used in the state is the signature constraint. Corda 4 uses signature constraint by default, so we do not have to do anything explicitly to enable signature constraint. Again, the jar would be signed using the Corda development key, as I stated earlier. So what we are going to do as part of this upgrade is we're going to introduce the new feature of challans, where police would be able to issue challans for traffic rule violation, which also means that we need to add new flows to our application. The new flows are available in version 3 of the workflow, while the new contract and states are available in version 2 of the contracts. So let's have a look at the contracts and state to understand what has changed. So version 1 of the states, as you can see here, has 3 fields, while if you go to version 2 of the states, we have introduced 2 new fields. These fields will be used to hold the issuer of the challan and the challan value, which is the amount of fine that is needed to be paid. We have also changed the constructor here and accommodated the challan value and the challan issuer. Make sure that you make the new fields nullable so that the previously issued states are still compatible and could be deserialized by the platform. And finally, we have introduced the getters for the new fields that we have added. And if you look at the contract, we have 2 commands here in the first version. And if we look at the version 2, we have 2 new commands that have been introduced for issuing of the challan and for settling the challans. The settlement of the challans is where the party pays the required amount to settle the challan dues. We are going to do the upgrade in the similar way that we did with the flow upgrade, and we are going to upgrade all the nodes other than party B so that we can see how different versions of the contract can coexist and parties are still able to transact. And once we have done that, we will upgrade party B as well and check that things are working by executing some transactions. So let's go ahead and do the upgrade. So to do the upgrade, I'll again use the upgrade script which I have been using earlier. Let me give an idea of how the upgrade script works. Basically, we have the nodes option where you need to pass the name of the nodes that you want to upgrade. And we have the workflow option where we need to pass the version of the workflow we want to upgrade to. Similarly, we have the contract option where we can pass the version of the contract that we want to upgrade to. So I'll just copy the script here and paste it on the terminal. And I should have my 3 nodes upgraded to version 3 of the workflow and version 2 of the contract. I would need to restart the nodes now. So before that, let me check if my Cordapp directory have the correct version. Yeah, party A has been upgraded. Party B is not upgraded. Police has been upgraded. And RTO is upgraded as well. So let me just go ahead and restart my nodes. Exit and restart. Exit and restart. And police, exit and restart. So while they restart, let me just again copy the commands that I want to run. So initially I want to do a registration to check if registration is working fine after the upgrade. Need to go to the RTO. This has restarted. I'll just wait for the other nodes to restart. And there you go. All my nodes have restarted, so I'm ready to do the registration. And there you go. So it works fine. Now you may notice that the registration involves the transaction between RTO and party A, and both of them are on the upgraded contract, so that should not be a problem. But if I do a transfer, this is a case where I'm transferring a vehicle from party A to party B, and party B is on the older version of the contract. So ideally, this should fail, and there you go. The flow has failed. That's because party B is on the older version of the contract and cannot verify a transaction that has been initiated with a newer version of the contract. In order for the transaction to go through, we'll need to have party B to be upgraded to the latest version. While if I do a registration with party B, well, party B is on the older version of the contract, this would still work because party B is not a signing party and he does not need to sign on the transaction. Thus, he doesn't have to run the contract verification. However, party B will not be able to receive the state that has been created by the registration flow. That's because Corda 4 introduces a change to the finality flow, which requires the nodes to run the contract verification before they record any update onto their ledger. And as party B is on the older version of the contract verification would fail and the flow would get checkpointed at party B's end. And when they upgrade the contract, the checkpointed flow would resume and they will be able to record the state onto their ledger. And to verify this particular fact that the state has not been recorded on party B's vault, let's run the vault query command on party B's terminal and check whether the particular vehicle state with registration number 2340 has been recorded or not. I've copied the vault query command and I'll run it on party B's terminal. And as you could see, the vehicles that are registered are 2323, 2322 and 2321. However, the vehicle 2340 is not available for the reasons that I mentioned earlier. And also to check if the RTO has been issued that particular vehicle, you could see here that we have the vehicle 2340 available with the RTO node. Another point that I would like to mention here is if party B initiates a transaction with any of the nodes that are on the newer version of the contract, then the transaction would actually be completed successfully. That's because the nodes with the updated version of the contract would still have the older version of the contract available in their attachment storage, and they'll be able to verify the transaction against the older version of the contract. Now the next thing that we are going to do is try and validate the new feature that we introduced. So let me just go ahead and try to run the issue challans flow. And to do that, I'll just copy this and I'll issue a challan against vehicle number 2325, which is registered with party A. For that, I need to go to the police terminal and run the command. And it has been successfully completed. To validate that the challan has actually been issued, I need to run the vault query command. You could see that the vehicle now has a challan value and the challan issuer. So next, let's validate the pay challan feature. So I'll run the pay challan flow using this particular command, and I would need to run it from party A's terminal because party A should be paying the challan. And as you can see that it has successfully completed. Again, verifying that the challan has been paid, I would need to run the vault query command. And the vehicle for which we issued the challan is 2325 and the challan value has now been reduced to 0, which means that the payment has been done successfully. Now let me go ahead and issue a challan for a vehicle that is registered with party B, and as you know, there is no flow that is available with party B since we did not upgraded party B to the newer version of the contract or the flow. This particular command should actually hang, and that's because there is nothing available at party B's end to respond to this flow. And as you could see, the flow would hang indefinitely and it has to be terminated manually by the user. I have basically used the Control C command to terminate the flow. As a next step, let's upgrade party B node, and to do that I'll need to copy this upgrade script and paste it onto the terminal. And once the Cordapp has been replaced, I need to restart party B terminal. So exit and restart. And now that it has restarted, let me just validate that the older state, which is vehicle number 2340, which was not recorded onto the ledger, has now been recorded. I'll just copy this and paste. And if you go up here, you could see that we must have the vehicle 2340. Yeah, here we go. The vehicle 2340, which was earlier not available before the upgrade, is now available in the ledger of party B. And now that we have upgraded party B, we should be able to run the transfer flow, which earlier failed before party B had upgraded. And to validate that, let's run the transfer flow using the particular command here. And I would need to go to the RTOS terminal to run the transfer flow, paste it, and you could see that it's running and it should successfully complete. And there you go. The transfer of the vehicle has been successfully done to party B. And that's because all the nodes are now upgraded to the latest version of the contracts as well as the workflow. Again, let's validate that we are able to do the issue of challan as well as the payment of challan. So I'll again select the same vehicle which I used before the upgrade and go to the police terminal, paste it, and as you could see, it's not hanging anymore and the transaction has been successfully completed. And again, let me verify that the challan has actually been issued. So I'll use the vault query command, and you could see that there is vehicle 2321 available here with a challan value of 5000, which was issued by the police party. And I can go ahead and settle the challan or pay the challan value using this particular command here. And let me go to party B terminal because the vehicle is registered with party B, paste it, and the challan has been paid off. So you can verify that. As you could see, the police doesn't have the record of that particular vehicle, which means the challan has been paid off. The next scenario that we are going to handle is only the contract upgrade without any state upgrade. So for that, we have the version 3 of our contracts where we have a simple change here. This is the version 3 of the vehicle contract where I have put this simple restriction where we cannot do a transfer of the vehicle unless the pending challans have been paid off. And there is no update to the state. The state is identical to the version 2 of the contract. And you could see that here. In this case as well, we are not going to upgrade all the nodes. We will leave RTO with the older version of the contract and upgrade the remaining nodes to understand how nodes with different versions of the contract could coexist and transact with each other. So let's go ahead and do the upgrade. And to do the upgrade, I'm going to copy this particular upgrade command, which would upgrade party A, party B, and RTO to version 3 of the contract, and then paste that in the terminal. And there you go. Now the Cordapps have been replaced and I would need to restart the nodes. Now that the nodes have restarted, I would run the transfer flow from the RTOS terminal and validate that the transfer is working fine. So you could see that the transfer would actually successfully complete even though the RTO is on the older version of the contract and is transacting with the parties who are on the newer version of the contract. Now this is again because of the same reason that I stated earlier, that the parties who have upgraded would still have the older version of the contract available with them in their attachment storage and would be able to verify the transaction against the older version of the contract. This is specifically a benefit of implicit upgrades where parties could choose to defer the upgrade if they're not ready to do the upgrade and can perform the upgrade at a later point when they're ready to do so. And to check that the transfer has actually happened, we can use the vault query and run this on the terminal, and here you go. The vehicle 2321 has been transferred to party A, which can be verified by this particular owner property here. The next thing, let me go ahead and do an issue challan. Now you could see that this will successfully work, but however, again the RTO will not be able to receive the updated state. That's because he's on the older version of the contract and will not be able to verify the transaction when he receives it from the finality flow, and the flow would get checkpointed, which would resume once he upgrades to the latest version of the contract. Now to verify that the challan has actually been issued, we can use the vault query command, and you could see that the vehicle 2325 has a challan value of 5000. However, if you use the same command in RTO's terminal and validate vehicle 2325, and there you go. The vehicle 2325 doesn't have a challan because he has not received the updated state. Now let's go ahead and do an upgrade for RTO as well. And to do that, again, I'll just copy this upgrade script here, which is this one, paste it onto my terminal and restart the node. And once it upgrades, we can again run the vault query command to verify that the updated state has been received by the RTO node. We'll wait for it to restart. And now that it has restarted, and I'm running the vault query command again, and you could see that the vehicle state has been updated. So all our nodes have now been upgraded, and finally let me just try to check the new functionality, which was we should not be able to transfer a vehicle. So for that, I'll just need to copy this and use the RTO terminal to run the command, and you could see the contract verification failed. That's because all challans must be cleared for vehicle transfer. And that's pretty much of implicit upgrades that I wanted to demonstrate. Next, we'll move ahead to the explicit upgrade part. In order to demonstrate explicit upgrade, we'll first issue some states using V1 contracts, and the state will be issued using the compatibility zone whitelist constraint. And then we'll do an upgrade to V2 contract explicit. The contract available at V2 contract explicit is over here. The thing to note here is that the contract must implement the upgraded contract interface, and we should have the verify logic, which is similar to the normal contract. And the important thing here is the get legacy contract method, where the ID of the legacy contract or the previous contract must be returned. And we also need to implement the upgrade method. The upgrade method is where we write the code to perform our state upgrade. Similarly, if you want to upgrade a state that is issued using hash constraint, then we need to implement our upgraded contract using the upgrade contract with legacy constraint interface. It's similar to the previous upgrade contract interface, other than it requires you to implement one extra method, which is the get legacy contract constraint method. The get legacy contract constraint method must return the hash constraint of the previous contract. And over here is the hash of the jar containing our previous contract. So let's go ahead and do the upgrade. So initially we'll do an upgrade for a state issued with compatibility zone whitelist constraint, and then we'll move to hash constraint. But before we do the upgrade, there are a few updates that we need to make in the workspace. So since I'm using Corda 4, signing is enabled by default, so I need to disable that. And to do that, I can use this particular thing. So I have just uncommented signing enabled false. And once signing is disabled, the default constraint that will be used is compatibility zone whitelist constraint. And another change that I have to do is in the build.gradle, I need to uncomment these two lines. What that would do is it would basically deploy the V2 contract explicit and V2 contract legacy explicit along with V1 contract and V1 workflow while we run the deploy nodes command. So let's go ahead and run the deploy nodes command. And once the deploy node command has completed, we can start our nodes. Now our deploy nodes command has executed and I have started the nodes as well. So let's go ahead and issue some vehicles for party A and party B. So to do that, I'll just copy the registration and transfer flow. What that would do is register two vehicles for party A and transfer one of those to party B. Yeah, we are done. So just verifying that we have the states issued using the vault query. Yes, we have some states here. Party A also has some states, and party B also has some states issued. So now we're ready for an upgrade. And to do the upgrade, I will run the Gradle command, which will run a client for me. This is the one. It would basically run the upgrade client, and what that does is if we go to clients and go to main Java, if you see, this is the upgrade client that we have. What it does is it basically connects to the node using the RPC endpoints and tries to call the contract upgrade authorize on all the unconsumed states for all the parties, or party A, party B, and the RTO. And then once all the states are authorized for upgrade, it finally runs the initiate method. The initiate method is inside this particular flow which I have written, and if you go in here, it actually calls the contract upgrade flow.initiate. So let's go ahead and run the upgrade. Let's copy this, paste. The upgrade has now been successfully done. If you could see the logs here on the terminal, and we could verify that the upgrade has been done by executing the vault query command again. And as you could see, there are no states available because all our old state has been consumed and the new V2 states has been produced. So we can do the query again, and you see that the V2 states are now available while the V1 states are consumed, which means that the update has been successfully completed. You could also verify the same in the party A's terminal. There's nothing with vehicle state, and with vehicle state V2, there are some states available. Similarly for party B, nothing with vehicle state, and vehicle state V2 has a state. So that's about compatibility zone constraint explicit upgrade. Now let's move on to hash constraint. In order to issue a state with hash constraint, we will have to do a little bit of a change to our registration flow, where we'll have to explicitly specify that we want to add a state which should have hash constraint. And that's what we have done here. We'll have to comment these, and then when we add our output state, we provide the hash attachment constraint as our preferred constraint. And once we have done that, we can go ahead and do our deploy nodes and then start our nodes. The deploy node task has been executed successfully, and I have started the nodes as well. So let's go ahead and do our last bit, that is to do an explicit upgrade for states issued with hash constraint. And before I do an upgrade, I'll need to issue some states. And to do that, I'll run the same commands that I used earlier. This will basically register two vehicles and do a transfer of one of those vehicles. So that's vehicle number 1, that's 2, and that's the transfer. So the command has been executed, and let's just verify that with the vault query command. The vehicle states are issued for RTO. It's issued for party A as well. Let's check for party B. And there you go. We have the vehicle available at party B as well. So it's time to go for an upgrade. And to do the upgrade, I'll again copy the Gradle's task and use the terminal. The upgrade has now been done, and what it would have done is basically it would have consumed all the previous states and issued the new states. And we can verify that again using the vault query command with vehicle V3 state. Before I do that, let me just go ahead and check what happened to my previous states. So I'll just run the previous vault query command, and you could see that the states have been consumed. Similarly for party A as well and party B as well. So let's now verify that the vehicle V3 states have been created. It's available with party B and party A as well, and with the RTO. So there you go. You could also verify that the hash constraint is used, as well as the contract that is used is vehicle contract V3. That's all for this video. I've demonstrated how to do implicit as well as explicit upgrade in Corda, and I also demonstrated how to do flow upgrades in Corda. I hope you liked this video and it helped you to understand how contract upgrades work in Corda. Thank you so much for watching, and I'll see you in the next video. Goodbye.